compare the domains of function A and function B. So I can see function A is f of x equals log of x, and function B gives me this graph. How am I going to figure out the domain of each in order to compare them? Chloe is here with her latest tips and tricks. She wants you to know that domain is about the x values and the range is about the y values. If you have a function in the formula f of x equals a over x minus h plus k, your vertical asymptote is equal to x equals h. X-intercepts are when you set your y equal to 0, and your y-intercept is when you set your x equal to 0. Now that we have Chloe's tips and tricks, let's go ahead and compare the domains of function A and function B. So the first thing I notice in function B, it doesn't give me the equation at all. It only gives me the graph. So I'm going to go ahead and graph function A, and then I'm going to look at both graphs to get the domain. Now, on function A, I have f of x equals the log of x. I'm not really sure exactly what points this goes through, so I'm going to go ahead and make an xy chart. My x values are just x values I randomly decide. I decided to try 0, 1, and 2. In the center, I put my function f of x equals log of x, and on my right column, I have my y, also the f of x. So I'm going to go ahead and plug in 0 everywhere there's an x, so I have log of 0. When I take the log of 0, it actually gives me an error in my calculator. It's actually undefined there. When I plug in a 1, log of 1 is 0. When I plug in 2 for x, log of 2 is equal to approximately 0.3. So if I was going to graph this, first of all, I would have graphed 0, undefined, which is nothing. So the fact that it's undefined at 0 means that there's actually a vertical asymptote right at the 0, x equals 0 line. So then if I was going to graph 1, 0, it would be right there, then 2, 0.3. And remember, the more points you can plot in your XY chart, the more you'll get for your graph, dots for your graph. So after you've done a few, you'll start to see that it curves down here, but as it gets closer to 0, it goes all the way down very close to that asymptote. It doesn't actually touch x equals 0. Then I can go ahead and get my domain from there. Remember, according to Chloe's little tips and tricks over here, the domain is the x values. So it's my horizontal axis. So as I go left on my x-axis, my function is getting closer and closer to what x value? Getting closer to 0, but it doesn't equal 0 because at 0 it's undefined. So on this problem here, I know my domain goes to 0, and as I go to the right on my x-axis, my function goes to infinity. Another way that you could write this is all real numbers greater than 0. Remember, greater than doesn't actually equal 0. Now, if we're going to look at the domain of function B, I can see that it starts right here at x equals 1, and then it goes to infinity. So as my domain, my x goes to the left, I get closer and closer to what value on my function? 1. And it does include 1. Notice how it starts right here at 1. As I go to the right, my function goes to positive infinity. So I do include that 1 there, so I have a bracket there. Another way I could have written this is all real numbers greater than or equal to 1. So either one of these answers would have been appropriate for function B and function A. So all we did was compare the domains between the two functions together.